Chapter 9, Lesson 4, Operations with Functions. You might have noticed we skipped Chapter 9, Lesson 3. If we're given two functions, we can do operations between these two functions. If we have f plus 3, that's the same thing as writing the function of x plus the function of g. In this case, it would be 2x squared minus 10x plus x minus 5. When I'm adding two functions together, I have to combine my like terms. So my like terms would be my x's. My final answer here would be 2x squared minus 9x minus 5. If I'm given f minus g of x, that's the same thing as the function of x minus the function of g. So it would be written as 2x squared minus 10x minus x minus 5. And when we subtract functions from each other, I have to make sure to distribute my negative sign to everybody on the inside. I always just change this to adding and change my signs on the inside of the function and combine my like terms. So my final answer would be 2x squared minus 11x plus 5. If I have f times g of x, that's the same thing as the function of x times the function of g. And in this case, it's going to be 2x squared minus 10x times x minus 5. And I have to FOIL. I have to multiply my first, so this would be 2x cubed. My last would be negative 10x squared. My insides, negative 10x squared. And my last, which would be positive 50x. So I can combine my like terms here, and my final answer would be 2x cubed minus 20x squared plus 50x. And finally, when I have the operation of dividing, which we just went through in Chapter 8, it would be 2x, my function of x, or of f, divided by my function of g. So the first thing when you're dividing, you always want to factor. When I'm looking at 2x squared minus 10x, I see that they both have a 2 in common and an x in common. So I'm going to factor out a 2x. On the inside, I'll be left with x minus 5. If the problem says find the domain or find excluded values, before I simplify, I have to make sure to find out what x cannot be. Since the bottom of the fraction cannot be equal to 0, I set the bottom cannot equal 0, and I solve for x. So in this case, x cannot equal positive 5. When I simplify, I can cross out both my x minus 5 on top and bottom. That would be my final answer. For the next problems, I would like you to try them by yourself and then compare to the problems that I do on the board. For my first answer, my first problem, I'm going to have the function of x plus the function of g. In this case, you should always write your final answer in standard form. And then I'm going to have the function of x minus the function of g. I have to distribute my negative sign and combine my like terms. Again, write your answer in standard form. Standard form meaning the highest power first. I'll have the function of f times the function of g. I'll have my first, outside, inside, and last. Here I cannot combine any, there are no like terms, but you should still write your answer in standard form. So x cubed would be first, then plus 3x squared, then minus x minus 27. And the function of f divided by the function of g. I should factor the bottom. Two numbers that multiplied to get -9 but add together to get 0 will be +3 and -3. And I should find my excluded values. In this case, I put both x plus 3 and x minus 3 cannot equal 0, leaving me with x cannot be +3 or -3. Since this is being multiplied in between here, I can cancel out x plus 3 on top and x plus 3 on bottom, leaving me with 1 over x minus 3. Whenever you cross out everything on top, you're still left with a 1. Fog. Fog means whenever this O here, a small o on top, means the function of g inside the function of f. This function of g is inside the function of f. If I were to give you that the function of f is equal to x plus 2 and the function of g is equal to 5x. If I'm going to find fog, that means the function of g I know is 5x. So instead of writing function of g like I do up here, I'm going to write 5x because that's what function of g is equal to. And whenever I have the function of f in replacement of just an x, that's saying wherever I see an x, this is my function of f, and whenever I see an x, I replace it with whatever is inside my parentheses. So in this case, inside my parentheses is 5x. So instead of writing x first, I'm going to write 5x plus 2. And this is what fog would be equal to. Now, just like how you have fog, you could also have goth. Goth is saying that the function of x, or of f, is inside the function of g. So I know my function of f is equal to x plus 2. So instead of writing function of f here, I'm going to write g x plus 2, because that is what the function of f is equal to. Now, since I don't have the function of f left, I look back at my function of g. So this is saying every time that I see an x, I write whatever is inside my parentheses. Inside my parentheses is x plus 2. So my GOF is equal to 5 times x plus 2, or 5x plus 10. Given that function of f is equal to 2x, and the function of g is equal to x minus x, or 7 minus x, find each value. This is saying work inside, out. So if I look on the inside, I'm left with my function of g of 4. So I'm looking at my function of g. What this means right here, this function of g of 4, it's saying evaluate the function of g at x is equal to 4. So my function of g at 4 would be equal to 7 minus 4, which is equal to 3. So that's my inside. Once I find out that the function of g of 4 is equal to 3, I can replace g of 4 with 3. So now I'm looking at the function of x evaluated at the value 3. So this would be 2 to the third, or 8. So you have to work inside, out. So this next b is same. First I have to find the function of f at 4. So I take my function of x is equal to 2x. So I'm replacing it with 4 because it's asking what is the value when x is equal to 4. 2 to the 4th is equal to 16. Now since I know that this whole value is equal to 16, I take my g of x at the value, which is equal to 7 minus x, and I replace x with 16. So 7 minus 16 will give me negative 9. It'd be a good idea to try these on your own to see if you get the same answers as I do. So if I evaluate the function of g first at 3, that's going to be equal to 3 squared, which is equal to 9. Then once I find out what this is, I replace my value of function of g of 3 with 9. I take 2 times 9, which is 18, minus 3 would be 15. And that concludes the function of g at 3. Here I have to find the function of f at 3 first, which would be 2 times 3 minus 3, which would be equal to 6 minus 3. So since this value is 3, I find the function of g at 3, which would be 3 squared, and this is equal to 9. I want to find fog and goth when I have two equations, two functions, function of f and function of g, and simplify. I also want to find the domain. When I find the domain, it usually is the numbers that x cannot equal. So if I find fog first, what I always do is write fog is equal to the function of f with the function of g on the inside. I already know the function of g. So that means when I start writing the function of f, anytime I see an x value, here's my x, I am going to replace it with this whole value because that is the function of g. So I'll have 5 times 2 over x minus 1 plus 2. I can distribute this 5 in. This is the same thing as 5 over 1. So it'd be 10 over x minus 1 plus 2. When I find my domain here, I want to find the values that x cannot equal. X cannot equal x minus 1. X minus 1 cannot equal 0 because that's the bottom of the function. So I have to add 1 to both sides. So x cannot equal positive 1. So that's my fog. Now I also want to find my goth. My goth is going to be equal to the function of f inside the function of g. Now wherever I see an x, I replace the function of g, this whole thing, in place of that g. So I'm going to start off by writing the function of g. I have 2. Now instead of writing x here, I write 5x plus 2. And I can simplify my plus 2 minus 1. So I'll have 2 over 5x plus 1. My domain will be 5x plus 1 cannot equal 0. So I have to subtract 1 from both sides and then divide by 5. X cannot equal negative 1/5. There are 2 more practice problems I would like you to try on your own. So I'm finding fog for the first one. This always helps me to rewrite function of g inside the function of f. So I always start off by writing the function of f. Anytime I see an x, I replace it with whatever g is equal to. And then I finish writing the function of f. So the only difference from this equation to this one is that instead of writing x, I write the whole function of g. So I distribute my 3 in. And I simplify. And I want to find my domain. Whenever x is with the square root, you can never take the square root of a negative number. So my domain here would be x has to be greater than or equal to 0. Because you can take the square root of 0, can't take the square root of any negative number. So I want to find goth now. That's the function of f inside the function of g. So instead of writing x right away, I replace the function of f. I can't simplify this any further because of that square root. But I also have to find out the domain of this function. The rules still are the same. The square root, you can't take the square root of any negative number. So what I'm going to do is if I set whatever is underneath the square root, set that equal to 0, because you can take the square root of 0, add 4 to both sides, and divide by 3. X has to be greater than or equal to 4/3. So just like how x has to be greater than 0 because of negative numbers, whenever you have a square root, you have to have x has to be greater than some number. Always putting whatever is underneath the square root equal to 0 to find out what that some number is. I want to find fog and goth again. So I start off when I'm finding fog writing the function of f. Anytime I see an x, if you're confused, you should box in where I see an x. And whenever I see that x, I replace it with g of x. So I'm going to have, instead of x, it'll be x over 1 minus x squared minus 1. Again, you don't have to simplify this. If you have this answer on a test or something like that, I would accept this answer. I do, however, have to find my domain. Whenever x is on the bottom of a fraction, I have to find out what x cannot be equal to. So x cannot equal 1 minus x. If I subtract 1, x cannot be equal to 0. So I put the bottom of the function cannot equal 0. I subtract 1 from both sides. Then I have to divide by a negative 1. So my domain is x cannot equal a positive 1. Because negative 1 divided by negative 1 will be a positive 1. And to find goth, I start off by writing the function of f, or the function of g first. This function of g, this has two x's. So in both cases, I have to replace both of these x's with the function of f. So on top, I will have x squared minus 1 divided by 1 minus x squared minus 1. I can simplify this by distributing my negative sign and combining like terms. 1 plus 1 will give me 2. So I'll have negative x squared plus 2. I have to find my domain. Domain is the same thing as find your excluded values. Negative x squared plus 2 cannot equal 0. So I have to solve for what x cannot equal. I first subtract 2 from both sides. Then I have to get rid of this negative on the outside. So that's the same thing as dividing by a negative 1. To get rid of anything squared, I have to take the square root. Now when you're taking this, when you're solving for a value and you're taking the square root, you have both a positive and a negative answer. Just like how negative 2 times negative 2 will give you 4, and positive 2 times positive 2 will give you 4. So you have to include both answers. So this would be your domain for goth and your simplified equation. Homework is on page 686, 14 through 34.